Good day, my name is CHANTAL HORTINELA and I will be the first to present our thesis, which is entitled as Design of an E-Attendance Checker Through Facial Recognition Using Histogram of Oriented Gradients (HOG) with Support Vector Machine (SVM) through the effects of luminance level, distance, and facial position in a classroom environment. The members are ALLAN, Jason C. ARCEO, RENEE, YLKA, and BOREJON, and me, CHANTAL R. HORTINELA. And our advisors are Engineer Arnold C. Paglinawan and Engineer Alejandro H. Ballado Jr. For the introduction, the conventional method of monitoring class attendance requires a considerable amount of time and is vulnerable to errors. Also, it was proven that checking of attendance correlates with the academic performance in educational institutes. And lastly, existing articles conducted different facial recognition systems but did not extensively consider some external factors that may affect the accuracy. So the main purpose of this paper is to design an electronic attendance, e-attendance checker through facial recognition system using histogram of oriented gradients with support vector machine by considering its conceptual framework, process flow, and implementation while considering the camera and class size optimization. This research specifically aims to determine the accuracy of this proposed system based in a classroom environment and to examine the effect of varying lighting conditions, varying distance, and varying face orientation on the accuracy of the system. For the methodology, our conceptual framework has an input of a RGB captured image of the students, and the process goes from conversion from RGB to grayscale, face detection using histogram of oriented gradients, cropping out of the faces, resizing of the cropped images, feature extraction using face landmark estimation, and face recognition using support vector machine. And the output will be a recorded class attendance sheet on an online database with authentication. Here is the process flowchart, wherein at the beginning it will capture an RGB still image and it will be converted to a gray image. After conversion, the facial detection via HOG will transpire, and after that, cropping of the facial image and resizing of the cropped images will be done. Later on, facial extraction using face landmark will transpire and facial recognition using SVM. At the same time, images of the students enrolled in the class are trained beforehand. Therefore, feature extraction using face landmark was already done beforehand and it will be stored in the database for comparison. If the image is identified, it will record the attendance. If not, it will drop the image and restart the process. And after the recording of the attendance, it will be uploaded to the MySQL database and it will output the attendance database. Here's the process flowchart for the access in the attendance database, wherein it will require a username and password authentication. If it is matched, it will access the database. If not, it will either repeat or end the process. For our hardware implementation, we have utilized a Raspberry Pi 3B Plus as a computing device and Raspberry Pi Cam V2 as our input device, with a external 0.45 times wide-angle lens attached to the camera. The setup of our system was implemented in a standard classroom, and its dimensions are 7.869 meters, 6.644 meters, and 2.791 meters for the length, width, and height respectively. Here's the actual setup for our camera and our RPi. For our software implementation, the program was coded through Python, and the library that provided the face recognition functions is the OpenCV library, and our GUI was developed using the PyQt library. And the output database is stored in MySQL, and to configure the database, it was done through PHP MyAdmin. Here is the sample graphical user interface that we were able to implement. And here is the authentication interface and sample output of our database.
Good day, I'm RENEE, YLKA, and BOREJON, and I will discuss some parts of the results and discussion of our paper. So for the data shown, it is the face detection with different camera lens. It is categorized with successful and unsuccessful detection with 3 different conditions. First is that the 0.36 times wide angle lens. Second is with a 0.45 wide angle lens. And lastly, the camera with no lens. So the data will be used to be able to know which camera lens option provides the most number of face detection. So for the camera lens analysis, we have a null hypothesis that states that lens does not affect the number of successfully detected faces, while the alternative is that the lens does affect the number of successfully detected faces, using the significance level of 0.05. Implementing the Fisher's exact test of independence, we calculated the p-value of 0.0465. Since the p-value is less than the significance level, we reject the null hypothesis and conclude that lens does affect the number of successfully detected faces. So with the data gathered, we can infer that 0.45 times wide angle lens provided highest detection. So now the data shown is the face detection with different camera positions, again categorized with successful and unsuccessful detection. So the reference camera position is that the camera is positioned where it covers the whole room. So the other conditions are left of reference, right of reference, above the reference, and below the reference. So again, implementing Fisher's exact test of independence, the null hypothesis is that position does not affect the number of successfully detected faces, while the alternative is that the position does affect the number of successfully detected faces, using again the significance level of 0.05. So calculating the p-value, we obtain 0.0442. Since the p-value is less than the significance level, we reject the null hypothesis and conclude that the position does affect the number of successfully detected faces. So the camera at reference position provided the highest detection. So now the data shown is the accuracy in a classroom environment where we started with 10 students and ended with 37 students and obtained the highest accuracy of 95.65 with 23 students. So it is condensed and categorized with smaller class size and larger class size, where the smaller class size include 10 to 24 students while the larger class size includes 25 to 37 students, and the sum of their successful and unsuccessful recognition were total. So implementing again the Fisher's exact test of independence with the null hypothesis that states successful recognition of larger class size is the same with the smaller class size, while the alternative is that the successful recognition of larger class size is less than the smaller class size. Using again the significance level of 0.05. Calculating the p-value, we obtain 0.64. Since the p-value is greater than the significance level, we fail to reject the null hypothesis and conclude successful recognition of larger class size is the same with the smaller class size. So the data now shown is the varying lighting condition with constant phase position. So we've totaled the successful recognition and unsuccessful recognition with the range of the lux. So for the varying light condition analysis, we've implemented t-tests for independence, with a null hypothesis states that no significant difference of lux between successful and unsuccessful recognition, while the alternative is that significant difference of lux between successful and unsuccessful recognition, with the significance level of 0.05, with the t-null equal to 1.99. So calculating the t-score, we obtain 2.23. So since the t-score is greater than the t-null, we reject the null hypothesis and conclude that significant difference of lux between successful and unsuccessful recognition. With the successful recognition that has a mean of 217.39 lux.
Moving on to the variant distance, we have our gathered data, consisting of 18 participants through 5 different trials, categorized into successful and unsuccessful recognition. Here we have the variant distance analysis. The null hypothesis is that the successful recognition is not dependent on the distance, while the alternative is that it is dependent on it. Significance level of 0.05, and using Fisher's exact test of independence, we acquire a p-value of 1. Now, since the p-value is greater than the significance level, we fail to reject the null hypothesis. From this, we can conclude that recognition is the same from 2.14 meters to 5.88 meters. Now for the varying phase orientation, first we consider the horizontal aspect. Our gathered data consists of 5 different participants through 5 different trials, again categorized into successful and unsuccessful recognition. The null hypothesis of the analysis is that successful recognition does not depend on horizontal angle, while the alternative is that it does depend on it. Significance level of 0.05 and a p-value of 0.00967 was acquired. Now, since the p-value is less than the significance level, we can reject the null hypothesis. From this, we can conclude that directly facing the camera provided the highest accuracy. For the vertical face orientation, again, we have 5 different participants through 5 different trials, categorized into successful and unsuccessful recognition. The null hypothesis is that successful recognition does not depend on vertical angle, while the alternative is that it does depend on it. Significance level of 0.05 and a p-value of 0.000034 was acquired. Since p-value is again less than the significance level, we can reject the null hypothesis. From this, we can conclude that 0 degrees and positive 10 degrees provided the highest accuracy, as seen from the data gathered before. Now, conclusion and recommendation. Face detection is done using HOG, while face recognition is done through SVM algorithm. Final attendance is recorded in an online database with authentication. The maximum number of persons in a single image tested in this system is 37 students, while the highest recognition was achieved through 23 students with an accuracy of 95.65%. For the specific objectives, first we have the luminance. It is found out that there is a significant difference between the luminance levels between the successful and unsuccessful recognitions. It is suggested that the classroom should have a luminance level greater than 217.39 lux. This value was acquired through the mean value of the successful recognitions. This is in order to achieve a higher accuracy performance of the system. For the distance, there was no relevant evidences to support relation between the distance and the accuracy. This just means that in a classroom environment, our system isn't dependent on the distance. For the face angles, recognition is dependent on the horizontal and vertical angle of the face relative to the camera. It is also suggested that the face orientation of the subjects yielded the best results when it is 0 degrees or in reference to the camera, directly facing the camera. For our recommendations, future researchers could look into newly innovated algorithms that could be used for facial detection and recognition. They could also look into other software for the programming and database. Also, usage of other hardware for a faster processing of data and a larger data capacity, and using other cameras that will be compatible to the hardware that they will use. References. This is our references used in this presentation and in the paper. With this, this concludes our presentation. Thank you for listening and have a great day.